Hello students, let us now begin chapter 2 of our textbook. And the very first topic is the coordinate system. Let us define so-called Cartesian coordinate system as follows. It's a scheme that represents various points on a plane through a pair of real numbers, x, y. So each point P can be represented as x, y, where x is horizontal distance to the right, and y is vertical distance upward. Let's look at some example. The simplest example is here, blue point, 3, 2. So from the center, which we call the origin, 3 units to the right and 2 units up. And we get here. Of course, we can go 2 units up first and then 3 units to the right. Either way, I'm going to get to the same point. That's 3, 2. It falls into this kind of scheme, x, y. How about the right point here, negative 3, 1, starting from the center point, which we call the origin. Now, negative 3 units to the right. I must go to the right because this is rightward, but negative 3 units to the right. That means I have to go 3 units to the left, and then 1 unit up. That's how I get this point here, negative 3, 1. Let's practice once more about those negative distances, starting from the origin. Now, I want negative 2, negative 3, the green points. All right. I want negative 2 units to the right. That's going backward. I have to move 2 units to the left. Starting from the origin here, I just moved my, let me remove this. Okay. Starting from the origin and 2 units to the left. Equivalently, negative 2 units to the right. And then I have to go negative 3 units up, or equivalently 3 units down, and that's what this point is, negative 2, negative 3. Similarly, we have 2, negative 2 here. And that's how we can represent various points in this plane by a pair of real numbers, x, y. Now, this horizontal line is often called the x-axis because that represents the horizontal distance, and rightward, so positive x is this way, and leftward is negative. Negative axis goes the other way. So we see this negative 2 here, negative 4 here, if you can see closely enough. Maybe you'll see better if I increase the font. Positive 2, positive 4, those are x coordinate. And then positive 1, positive 2, positive 3, those are y coordinate, the vertical distance upward. And these are negative because I have to go down, which means negative distance up. Those kind of things are called Cartesian coordinate system, named after French mathematician and philosopher Louis Descartes. Or it is called rectangular coordinate system because, as you can see, you have a bunch of rectangles, as you see in this blue rectangle or red rectangle, green rectangle, and brown rectangle here. Our textbook author uses the term Cartesian coordinate system, so I'll try to follow this, named after Louis Descartes. Now, another term that you must know are the concept of quadrants. This part is called first quadrant. This 1/4 is called second quadrant, third quadrant, and fourth quadrant. Here, both x and y are positive. So, positive distance to the right, positive distance up. Consequently, we got this point. Now, how about the second quadrant? X is negative, y is positive. So, negative distance to the right, which means go left. And then y is up, so go up. Now look at third quadrant here. X and y are both negative, which means from the origin, negative distance to the right, which means go left, and then negative distance up, which means go down. Similarly, we have fourth quadrant down here. So starting from here, first quadrant, second, third, and fourth in counterclockwise direction. Next concept, let's talk about the distance formula. And it's an important formula, so I want everybody to remember this, if not memorizing it. And it can be deduced from Pythagorean theorem. You have 2 points, x1, y1. Oops, excuse me, a typo. First point should be x1, y1. Excuse me, sorry about that. Let me correct the typo. Sorry about that. Let's see. Yes, x1, y1. So P1 is associated to index 1. So x1, y1, where x is horizontal, y is vertical. And then P2 is x2, y2. All right. Now everything is fixed. Okay, all right. Sorry about the typo. It's fixed now. x1, y1 is P1. P2 is x2, y2. And then we want to find out the distance between the two. But we can always inscribe a right triangle. Just move horizontally and then vertically. Or if you move vertically first and horizontally, you're going to get right triangle over here. But I decided to move horizontally first here. So we have this right triangle, as good as any. And then we can inscribe Pythagorean theorem. Hypotenuse square, this red square, is equal to blue square plus green square. Horizontal square plus vertical square. And what's horizontal? The difference of x coordinate, x2 minus x1 in absolute value. But we don't have to take absolute value because we are going to square it anyway, and square makes everything positive anyway. Same goes to y2 minus y1 in absolute value. We're going to take square anyway, so we don't have to worry too much about absolute value. And if you just add up square of those distances, blue and green, then you're going to get square of this hypotenuse. So we take the square root, and then you're going to get the distance from P1 to P2. If you don't remember this Pythagorean, you still have to be able to use this. So try to memorize this formula, and picture will definitely help you. Final topic here, let's talk about the midpoint formula. It's easy, just take the average. And why is it? Well, this picture explains everything. Similar picture as before. P1 is here, P2 is over there. And how do I take the midpoint? Well, form this right triangle again, our old friend. And then horizontally take the average so that horizontally we come to right in the middle. And do the same thing vertically. Vertically take the average. So the x1 and x2, the x coordinate becomes the average of this. And then y coordinate vertically also average. So average comma average, that's this midpoint is. So horizontally average, vertically also average. This picture says it all. Even if you do not remember the picture, you should still be able to use this formula. So here we go. But picture will of course help you memorize this. Okay, I have about a little bit less than a minute to talk about internal section point. Okay, let me talk about directly. Sometimes instead of taking the midpoint, we want to take the internal section, a point that divides this line segment in a ratio of 1 to 2. 1 to 2. So this distance is twice as long as that one. And this program is randomized, so you can run it again. And this is 4 to 2. 4 to 2, so it's 2 to 1. This distance is twice as much as that one. Let's run it again. 2 to 3, okay, so 2 to 3. So P1 to P is 2, and P to P2 is 3 in that ratio. And there's a formula. If it is dividing by m to n, you can put it into this formula, and when m and n are the same, 1 to 1, in that case we have the midpoint formula. Why did I talk about this generalized formula? Because we're going to be using it when you're dealing with the median of a triangle. That probably is the only example that you have to deal with in college algebra level, but here it is anyway. Alright, so much for section 1. Thanks.